Hi, everybody. I want to welcome you to pre-calculus. I see there's 46 people here. I have my setup working nicely, so I can see some people on video. Other people just have like a some kind of icon. It's up to you. Ethan has some kind of trick. Do you have some kind of method that gets you into the top left corner? That secret? You could just it just happens. Okay. Ethan's like my sidekick at on these things. Okay, good. Okay, so everybody can hopefully see a intriguing question on the screen, which is, can numbers be raised to imaginary powers? If you're, how many, raise your hand. I can see if the video people, raise your hand if you think numbers can be raised to imaginary powers. And raise your hand if you think numbers can't be raised to imaginary powers. So there's two questions here. What do you think will happen if you write 3 to the I power on your calculator? Take a second to ponder, and you could type in, you're into the chat. What do you think is going to happen? Is the calculator going to say error? And then you could actually, if you have your calculator, you might have left on Friday. I don't know. Do people just have their calculators with them at all times? You may not have the calculator. Interesting. So some people are getting, it's saying an error, and some people, it's not saying an error. Let me bring up calculator. Stop, share screen, whoops. And here. Okay, so now you see that, so I have this calculator up. And when I do it, 3 to the second, and then the decimal. Will mine say error? Maybe it depends on who you are, or if you have the magic touch. Okay, so mine did not give an error. It gave about 0.45 plus 0.9 I. Let's see, why did yours say it? Well, if you go to mode, there's all this stuff. And I'd be curious if you changed your setting down here, see where it says real, and if you change it to A plus BI and hit enter there, and then second quit, and now try 3 to the I power. Those people whose it didn't work for them the first time around, are they finding that it is working for them now? Let's see, chat. Okay, some people still getting an error. So it is possible that you have like the older operating system of the TI calculator. Like there's different operating systems, and you haven't updated it. So there is a way that we could update your operating system. But the good news is, for our purposes, what you need to know is that there is going to be an answer, and even if your calculator isn't showing that answer now, that's okay. We'll see what the answer would be on a calculator that that does it. Let me go back to the iPad. Screen share. Okay, back to this. There we go. Okay. So if you try another number, so here we have the 3 to the I apparently is 0.45 approximately plus 0.9i. And that 2 to the I power is a different number, 0.77 plus 0.63i. So that's kind of like interesting. Now, what these numbers are actually and how you could calculate them, even if you didn't have this kind of calculator, but what the rule is for like raising a number to imaginary power, rather than, oh no, it says my internet connection is unstable. Type into the chat if how are things looking for me here. Chat, does it look unstable? Okay, laggy. Okay, audio's okay. Okay. Here's a question for you to think about that you can use the chat for. Here I have two answers. Oh, so we're not going to like derive this because the actual derivation for the formula is kind of like involves some advanced math, like even involves calculus. However, let's make this more like a mystery. Based on these two answers, could we figure out what the rule is, what the how to raise numbers to powers, what the story is with these, the A and the B, the 0.45 and the 0.89i. Why doesn't everyone take a minute to, do you notice anything? Is there anything that these two numbers, these two answers have in common? Anything that the two numbers have in common? You can chat about that. Okay, Finn just said something very interesting. When he squared the 0.77 and the 0.64 and added it together, he got 1 or close to it. And that's true for the other one also. When does that happen? And yes, Finn says a potential rounding error. Yeah, it is true that they will be squared and equals 1. And Willis made an observation there, which is maybe it has something to do with sine and cosine, because sine squared plus cosine squared equals 1. Is anybody tempted to do anything with these complex numbers, the 0.45 plus 0.9i and the 0.77 plus 0.64i? Yes, Talia says to turn them into polar form. Go ahead, do the R. I saw inverse sine, Youssef. Inverse tangent's probably better because you have the sort of the B over A. So why don't you go ahead for each of these? Could you convert them into that trigonometric form, sometimes called polar form, the kind that is like R cosine theta plus R I sine theta? Okay, I see Derek says that for the first one, theta is about 63 degrees. Ahmed says that R equals 1. I'm its honorary member of the class. And at the other one, it's about 40 degrees. And R, for both of them, ends up being 1. So this one was, I'll write the 1 in, 1 cosine 63, approximately, plus 1 I sine 63. And the other one is 1 cosine 40, approximately, plus 1. So now the big question is, it seems like if you raise something to the I power, I mean, we're eventually going to raise to other things, you know, more complicated than I, 2I or 3 plus 4I, things like that. But at least now, at least based on these two questions, it seems like the answer is going to be R equals 1, and theta is going to be something that's going to depend on R. Not on R, on the base. But it's not really clear what's so special about 63 that relates to the number 3 and 40 that relates to the number 2. There's no real easy way to see that at this point, and you'll never guess it. But not for 3 being 63 and 2 being 40. You never guess the pattern. How is the angle based on this base? However, if I do e to the I power on the calculator, I get 0.54 and 0.85i, something like that. And this one's really important. R equals 1 again. But the question is, what is theta in the special case that I use the E, otherwise known as Eulers constant? And I see Riley saying 57 and Derek saying 57.3, 57.3. 57.3. That number sounds familiar. That's a very famous number. What's so famous about 57.3? Yes. And there we go. It's 1 radian. 57.3, 57.3 degrees, which is the same thing as 1 cosine 1. I'll put a little r there for radian, plus 1 I sine of 1 radian. So for the special case of e to the I, the theta is 1 radian. And here is what you get for e to the 2I. And I'll just tell you that r is 1, but theta is 114.2. So what do you think the general rule is for e to the theta I? Okay, and I see theta radians, which is right. This is one of the most famous rules in all of math, that e to the theta I, so the theta is the coefficient of the I, it will equal cosine theta plus I sine theta. And this is one of the few rules of the whole semester that we're not we didn't derive it. It's more like a mystery. We like had this calculator which was saying some stuff, and we messed around and found it. When they invented this idea, they didn't have this option of like a mystery. They had to like invent this. And I'm not getting into in this lesson why this is true, but it seems to be true. At least it's true for E, and it is extremely, extremely famous rule. Now, and make a note, theta is in radians. This theta. Now, if I want to know e to the 2i now, I can say cosine of 2i, sorry, cosine of 2 radians, remember radians about 57.3 degrees, plus I sine 2. Well, that's fine. I have a calculator, and for this, I could turn my calculator into radian mode, and you should now. I'm going to come over here and do stop share, and then I'm going to do screen share and come back over here. And I can come over here, and I'll show you that if I do, second ln is e to the, and if I do second decimal point, sorry, let me get to the 2i power, 2 second decimal point. And if I come over here and go mode, and I'm in radian mode, my calculator is defaulting, but put yourself into radian mode. And if I do cosine of 2, literally 2 radians, we get the negative 0.41, and sine of 2, I get that other number. So this is basically there's actually some time later on in the semester where we'll use radians, but this is the big one where we will. Second. Now, well, that's good for e to the 2i, but we don't know, oops, let me go to back to the iPad. Wait, iPad, share. Okay, I hope there is it coming there. Back to the iPad. Now this is great, except usually I don't know what cosine 2 without a calculator. But there are some questions I can do now with no calculator. Like this one. You can now answer this question all the way down. You don't need a calculator because pi over 6 is a nice number. Why don't you, in the chat window, type in what you think the answer is to this question. And an extra shout out to Derek for making a square root sign. Derek, how do you make that square root sign? Kind of ASCII code? But it is, yes, it is. It's going to be cosine of pi over 6 plus I sine pi over 6. Cosine of 30 degrees is radical 3 over 2. And sine of pi over 6 is 1/2. So even with no calculator, we can do this pretty, looks like a pretty hard question, e to the pi over 6i, but we can do it with no calculator. Okay, what if instead I make the coefficient pi over 2? Option C. I'm going to try that. On a Mac? Nope. Option V? Option V. Everyone's having fun with their newly found square root thing. Okay, and you can type your answer in. Riley, I think that's pi over 4 because, so we have cosine pi over 2 plus I sine pi over 2. Pi over 2 is like 90 and cosine 90 is 0 and sine of 90 is 1. So e to the pi over 2I is actually just I itself. And one more sort of interesting one. What about just e to the pi I? Here, if you're there's not that many people who I can see on video, but if you're one of those people and you want to raise your hand, I will I'll unmute you to explain your answer for this one. I only have 12, 11 people who I can see actually. Well, let's just say their answer just to get a little bit of participation there. Okay, people are shy too, but I do see answer of -1, which is the right answer. Cosine of pi plus I sine of pi is equal to cosine of 180 is -1, and sine of 180 is 0, so it becomes -1. If you forget those rules, I personally picture the sine curve and the cosine curve. So if I forget what 180 is, well, I can see 180 is like halfway through each of them. E to the pi I equals 1. If you were to take that and add 1 to both sides, you would end up with this equation. And that equation is often called Euler's identity, E-U-L-E-R. It's spelled Euler, but pronounced Euler identity. And on everybody's list of the most amazing or greatest or most beautiful math equations of all time, this makes every single person's top 10 list. In fact, I looked this up. I was sure that it would be there somewhere, but people get tattoos of that. I'm not saying that you should, just saying that some people have e to the I pi. They have the I before the pi. I don't know if they can get that changed at this point. How do they have it here? See, I pi. Oh. Anyway, this formula is very famous because it connects 7 of the most fundamental, and no, that is not my arm. Now, e to the I pi plus 1 equals 0 connects 7 of the most important symbols in math, namely 0 and 1 and plus and equals and pi and I and e, all in one formula. Here, and no, I'm not going to bet this class. Now, what if there is a it's a complex number like 3 plus radicals, 3 plus pi over 6i. So now it's not just something I, but it's got this other stuff. Anyone have a thought about what to do in this case? And Syed says, split it up. And he's exactly right. E to the third times e to the pi over 6i. It's kind of undoing the usual rule where when you multiply two things with the same base, you add the exponents. So this becomes e to the third, and we had this from before, radical 3 over 2 plus 1/2 I, and then distributed through to get e cubed radical 3 over 2 plus e cubed over 2I. So even if the exponent has a real part, we can do that. But there's a lingering question. What do we not know how to do still? That's right. I see Willis, Leo. What if the base is not E? Uh-oh, it says my internet connection is unstable. Okay, some other number to the I power, like 3 to the I. Remember 3 to the I became cosine of 63 plus I sine of 63? What was that? What was that 63 degrees? It wasn't 1 radian. It was more than 1 radian. Well, you can rewrite 3 as e to the ln3 to the I power. Because ln3 is what you have to raise e to get 3. So e to the ln3 is a fancy way of saying e to the ln3 is a fancy way of saying 3. So this becomes e to the ln3I, which becomes cosine of ln3, that's ln3 radians, which is a little bigger than 1, plus I sine ln3. So that 63 degrees was apparently ln3 radians. If you type into your calculator, in fact, I am going to switch over to the calculator to show that. Stop share, share screen, this window. So if I come back over here and I say cosine of ln3, I'm going to get the 0.45 from before, and sine of ln3 is going to get me the other number. So ln3 radians is the 63 degrees. And that's how you raise something other than a different base. But there's one more type of base. There's E. There's real numbers other than E. But what about the age-old question, is it possible to raise I to the I power? And let me get the chat window up. There we go. Okay, so I to the I. And if I come to the calculator, it wouldn't be surprised if the calculator said, you know, you're asking me to do a little bit too much here. But when I push enter on the calculator, surprisingly, it doesn't even, it gives 0.2078. It's not even, it's a real number. It's not, it doesn't even have an imaginary part. It's just 0.2078. So the final thing for today, the final thing, and then this lesson is actually done. Let me switch back to the iPad. Screen share. Oops. Screen share. This will stop others. Do you want to continue? Okay. We get a peek at other people's computers for a second there. I to the I power. And hold on a second. I have a lot of windows going around here on my screen. I want to get the chat back. Where's that? There it is. Okay. Let me just get back to this. Everyone in meeting. I to the I. I cannot. You might suspect. Why don't I say e to the ln to the I? I mean, it does equal that, but that has its own problem because I don't know. I don't know what ln is, and I don't even think your calculator could do ln. But there is a sneaky way to do it. Do you remember a couple of slides back? We saw that e to the pi over 2I is the same thing as I. So if I replace this I to the I with e to the pi over 2I and raise that to the I power, now I can multiply the exponents together, pi over 2I squared, which is e to the negative pi over 2, which is 1 over e to the pi over 2. And that's why the 2079 thing that came out, that's why it's not so surprising that it became a real number, because e is a real number and pi over 2 is a real number. So e to the pi over 2 is going to be a real number, and 1 over it is also going to be a real number.